Welcome to the What Works Clearinghouse training focused on introducing the design comparable effect size. You can find more information about the WWC at the WWC website, whatworks.ed.gov. This module broadly describes the design comparable effect size, sometimes abbreviated as D-CES. It describes why the WWC uses the design comparable effect size for single case designs, briefly describes how the effect size is estimated, and then describes how to use a point-and-click application to calculate the D-CES. After completing the module, you should understand why the WWC used the effect size and how to calculate it when appropriate. Let's discuss why the WWC uses the design comparable effect size. This effect size, also sometimes called the design comparable standardized mean difference, or the between cases standardized mean difference, represents the standardized mean difference for a hypothetical group design study that examined the same population, intervention, and outcome. This means that the D-CES is comparable to the Hedges G the WWC uses to estimate impacts from group designs. It also means that the D-CES can be synthesized or combined with Hedges G effect sizes from group designs the WWC also reviews. At the present time, there are not effect sizes for all of the designs that the WWC reviews. Currently, there is a form of the D-CES available for treatment reversal withdrawal designs, and a form of the D-CES available for multiple baseline and multiple probe designs. And these are the scenarios where the WWC will calculate a D-CES. Effect size development is an active area of research, and as additional forms of the D-CES become available, the WWC intends to expand use of the D-CES to additional designs. There are some additional requirements beyond the specific designs for estimating effect sizes from single-case designs. First, the effect size can only be estimated from studies where there are 3 or more cases using the same design. Remember that cases could be individuals, but they also may be a cluster, such as a classroom. This means that a study using treatment reversal designs would require the same treatment reversal design to be replicated across 3 or more cases. Most baseline designs across cases will have 3 or more units, and if they meet standards, it will generally be possible to estimate an effect size. However, it would not be appropriate to estimate an effect size for a multiple baseline design across contexts for a single case, even if it had 3 or more tiers. In addition to requiring 3 or more cases, all the cases must use the same outcome. For instance, if a study designed to examine the effect of an intervention on social behavior measured a pro-social behavior outcome for 2 students and an antisocial behavior outcome for a 3rd student, these data could not be used to estimate a design comparable effect size because the outcomes varied across cases. Finally, unlike the other effect sizes that the WWC uses, it is not possible to estimate a D-CES from summary statistics reported by primary study authors. Rather, estimating a D-CES requires access to the individual data points. Most of the time, these individual data points will be available in the form of a plot, although occasionally they might also be provided in a table. The forms of the D-CES the WWC uses are estimated via multi-level modeling. The simplest form of the model is presented here. The model is Yij equals A plus B Tij plus Ui plus Eij. In this model, Yij is the observation of unit I at time j. A is the average outcome in the absence of the intervention. B is the intervention effect that is assumed to be normally distributed across units. UI is the error term, or the average deviation from the overall average for unit I. These deviations are assumed to be normally distributed with a mean of 0 and a variance tau squared. EIJ is the level 1 error term, which is assumed to have a mean of 0, a variance of sigma squared, and a first-order autocorrelation, sometimes referred to as phi. The effect size G is then calculated as the average intervention effect divided by the square root of the sum of the between case and within case variances. This is similar to the effect size calculations the WWC uses for group designs, where we divide the unstandardized mean difference by the pooled standard deviation. The standardized effect is then multiplied by the small sample size correction factor, omega, which is specific to the D-CES and can be found in Appendix E of the handbook. Finally, there are additional modeling options for multiple baseline and multiple probe designs that reviewed teams, but not individual reviewers, have the option to employ. These include options for more complicated functional forms, including within and across phase trends. Time for your first knowledge check in this module. A researcher examined the effects of 3 different language interventions, Intervention A, B, and C, for improving expressive language use in children with autism on 3 preschool students. They used a randomized alternating treatment design with no more than 2 contiguous data points per condition. The study has 3 intervention comparisons: A versus B, A versus C, and B versus C. The A versus B comparison was rated meets WWC standards without reservations. The A versus C comparison was rated meets WWC standards with reservations. The B versus C comparison was rated does not meet WWC standards. For which comparisons would the WWC estimate a D-CES? Your 3 possible answers are A, the A versus C comparison, B, both the A versus C comparison and the A versus C comparison, or C, none of the comparisons. You may want to pause the video now to think about your answer. The correct answer is C. Although comparisons that meet the WWC standards are potentially eligible for effect size estimation, at the present time, the WWC cannot estimate effect sizes from the findings from alternating treatment designs. However, as we discussed earlier, this remains an area of active research, so that could change in future updates to the WWC standards. Knowledge Check 2. A researcher examines the impact of a choice-making intervention for children with autism on 4 children in 1st through 3rd grades. She uses treatment reversal design to observe the intervention's effect on disruptive behaviors during in-class work time. 2 of the participants' experiments are rated as meets WWC standards without reservations, and the other 2 participants' experiments are rated as meets WWC standards with reservations. Should a D-CES be estimated for the study? You may want to pause the video now to think about your answer. The correct answer is yes. The WWC would estimate an effect size. All 4 findings met the WWC standards, and there were at least 3 participants, so the WWC would estimate an effect size from the 4 study findings. The effect size would receive the highest research rating for any finding contained in the effect size, so the research rating associated with the effect size would be meets WWC standards without reservations. Time for your final knowledge check. The plot to the right is from an SCD examining the impact of a function-based intervention intended to reduce externalizing behaviors in students at risk for behavioral disorders. Assume the findings displayed in the plot to the right received a research rating of meets WWC standards with reservations. Should a D-CES be estimated for this finding? You may want to pause the video now to think about your answer. The correct answer is no. An effect size should not be estimated from this finding because the study design is a multiple baseline across context designs. In this example, although the study finding received a research rating of meets WWC standards with reservations, there are not enough individuals in the study to estimate an effect size. Andre is one student, and estimating a design comparable effect size would require 3 or more students.